Hi guys. This is a video on just stata stuff. I thought like a lot of people are having trouble with stata, especially in the run up to something. Yeah, so an unspecified project. But yeah, this is just a video on sort of just how to use it. I guess think of me as just sort of like a little bit of help. I guess I'm not here to do a project for you. Okay. I'm not here to give you stuff to do on your report or anything like that. I'm just here to tell you how to use stata and how to properly like go about using it. If you want to figure out how to use it well. Okay, first of all, let's show you guys some basic stuff. So, I've got my stata terminal on the left here, and I've got my cheat sheet on the right here. Now this cheat sheet, apparently a lot of people don't know it exists, so I'll be putting it in the description. But this is very useful. It gives you all the stuff you really need. Okay? One important one to first sort of start off with is summarize. This is normally just written as sum. This will summarize all your variables for you. So you can see here, we've got 3,509 variables. You've got the means, the standard deviations of those variables. You've got the minimums, the maximums of those variables. Important stuff, pretty much. What's also notable is that one of them doesn't exist. Hold on, let me go back there to 04. One variable doesn't exist, just so you guys know. So let's see. Here's the submission. Oh, it's scary. It's coming up. It's very scary. What is it? Oh, yeah. Okay, hold on. Yeah, so if we look here at the variable list, relationship status dummy doesn't actually exist, which is a weird thing. But marital status dummy does exist, okay? So it's a kind of a different thing. It's not relationship status, it's marital status. Okay, so just make note of that. And I think there's one more that doesn't actually exist in this, but you just have to look out for that. Okay, so first of all, let's go through some basic analysis, okay? So you can get an estimate of means. So for example, if we, also correlations as well. So if you want to correlate, I think just core will work. So say core, and if we want to correlate, I don't know, let's say job tenure weeks and salary, it'll give us, I put a backslash at the end there. Always got to be careful when you say things. Yeah, it'll give you a correlation coefficient, so you have correlation stuff there. Correlation is not really what we want though, we want regressions. Okay. So if you want to do a regression, we'll just write reg, and then we'll write our values. So let's say we want to use job tenure hours. We want to use, let's say salary. Let's say work hours, right? Oh, sorry, not job tenure hours. We want job tenure weeks. I always forget the names of these variables. They're all very weird. Yeah. So this will give us our regression stuff. So you get the number of observations here, which should be all of your observations. You've got the R squared, which is low, which shows that there's a lot of basically unexplained variation in this data set, which is completely fair. There's a lot of variables at play and a lot of different kinds of things, okay? So the R squared, okay, there's going to be a lot of variation in this. That's just how it is. There's going to be a hell of a lot of variation. So you can use that as an analysis. So you can say, okay, there's a lot of variation in here, so we shouldn't take it as given. But you can also say that, like, quite clearly, it's not necessarily like, because there's going to be a lot of variables. So generally when you have a lot of variables in a data set, there's going to be a large R squared value. But you can see here, in just this, if we just regress for salary and work hours, we can see that salary has a positive effect and work hours has a negative effect, as expected. But if you were to do other regressions, you may have different coefficients, is the main thing. So you would have coefficients that would be different. So if for example, if I included, for example, something like age as well into this, you can see that work hours is now more pronounced and age is now even a doubling factor. So you can see age would have like nearly a doubling effect on job tenure hours, pretty much. But yeah, however, this isn't necessarily correct, okay? Because this is not actually the percentage change, okay? This is not the percentage change. This is because I've just done job tenure weeks as a linear variable. I have done it as a log variable. Now, a lot of people are confused how to actually generate a log variable, so I'll show you now. Gen, which is to generate a new variable, and then you're going to list what your new variable is. I just did lin job tenure weeks, and that's how we do it. And then we set equal sign, so we know like what we want here. And then what we do is we do lin brackets, and then we're going to write just job tenure weeks. Job tenure weeks. And there we go, it's generated. Now I can redo my regression that I just did, but I'm going to replace job tenure weeks with lin job tenure weeks. And now you can see the percentage change. You can see it's quite different now, right? The salary now has a 3% effect, okay? Barely anything. Well, actually, not even a 3% effect, would it? No, it's a 0.3% effect. Work hours has a 0.1% effect, and age has a 2.6% effect. And you can see you've got the constant here, all right? It's important to do a lin regression here to show the percentage changes, okay? It gives you a much more accurate look at things. Now, I'm assuming you guys already know how to do most of this, so I won't go over too much in the regression, okay? There are other types of regressions, but I wouldn't recommend using them. So, for example, you can see here that there's a lot of different models. You've got regress, you've got regress in if something is like that. So, yeah, we can also regress for just the specific age range. So, for example, let's try doing this. Regress if, and let's say if the person is male, for example. So, if the gender dummy is equal, two equal signs, remember, if gender dummy is equal to 0, this will return us values for the male subsection of the population. And then we want to go for regress gender dummy 1. And this will return values for the female section of the population. We can see that there are not too many differences, apart from a few notable ones. So you can see that basically the salary has about a 0.5% effect, and the salary is 0.2% effect with women, which is a different thing. Work hours is a negative for both groups in similar things, and age is the same. Although women have more of a pronounced coefficient in age and less of a pronounced coefficient in salary. So that could be something to look at. Okay? So a lot of these are pretty much like that. Now let's look at dummies and what they can sort of tell us. Now, what's important about dummies is that they're binary values. And what's fun about what you can do with them is that you can put in a tabulate command. Now, tabulate commands are very, very important at looking at the attributes of the data. So let's look at tabulate. So tabulate is pretty much tells you how is my data distributed almost. There's other ways to show how data is distributed, but tabulate is quite useful. So let's say we're asking a question: how many women compared to men, for example, think that their company have good benefits or something like that? So what we want to do is we want to include the gender dummy for the gender effect, and we want to include company good benefits. And then what that's going to give us is this table here. This table here tells us, okay, this is the row for females, this is the row for males. We can see here, this is employer generous benefits, and this is employer non-generous benefits. Okay. We can see that out of all women, 282 out of 1,816 think their company has good benefits, and out of men, 217 out of the 1,693 think their company has good benefits. We can see that this is fairly distributed, so this isn't really as much of a significant change, okay? So this is completely fair, all right, given the proportion. But yeah, we also may want to figure out other things. So for example, if a company provides sick leave, how likely are they to provide paid leave? So we'll tabulate sick leave and paid leave. And we'll get another graph like that. So we can see that companies that provide sick leave are more likely to provide paid leave, but companies that provide paid leave aren't necessarily more likely to provide sick leave. In fact, it's about a half and half chance. And we can see that most companies don't provide either. Okay? This is important information if you want to figure out what your data set is actually telling you. Okay? It's important to understand what the data set is actually, actually comprised of before going into conclusions that might be incorrect. So we may want to also think about other ones here. Also, all this stuff is included on here, in case you guys need it. Some part of this isn't particularly necessary. For example, data transformation. You shouldn't be retransforming the data because that's not what this is about. You should just be using the data set as it is. Data processing. Some of this may be at best. I mean, something like a basic data operation or changing the types of the data, something like that. But nothing here is really in the orange section. Is very important. Actually, hold on. I think I have dark reader on, so it may look a little different for you guys. But yeah. Now, data visualization is an important one. So one interesting thing you can do is a k-density graph, which is this one here. It's sort of like a smooth histogram and shows you the distribution of the data. So if I write k-density, and that's all I need to do, and I write one variable here. So let's say I want to do k-density of age. Oh, again, I did a backslash at the end. Oh, I did a backslash at the end again. There we go. And give it a second. There we go. So what this is essentially telling me is the density of ages in my group. We can see that it's generally a bit more of a triangular distribution. Things are generally quite weirdly distributed. You can also see that there are flattenings around some areas. So we can see that there's a dramatic spike around 20, then it flattens off at 30, and reaches a peak around 40 and 50. So you can see that the majority of the data set belongs to people over the age of 40, pretty much. We can see that there are less young people in this group as well. It's mostly those who are more elderly, which is the main thing. Okay, this is important stuff to know. If, for example, you may also want to figure out what's the distribution of job tenure weeks as well. Again, this is important stuff to know. And if we look at it, we can actually see that this is quite a weird distribution. Okay, we can see we have a peak around, what is that, 20-ish? Actually, let's just check. Mean of job tenure weeks. We can see that there's a mean around 82, but that's not necessarily correct. What if I want a median? What's the median value? Oh well. But yeah, where did I go? Where's the graph? It's here. But yeah, we can see that there's generally a distribution that's centered around the bottom length, and then it's very much of a long drop-off. So most people don't necessarily, I mean, like you would get longer job spells in like more stable jobs, but you wouldn't get that there. Actually, thinking about that, you could talk about using the Tabulate command again. Job tenure weeks and main job dummy to see if actually I'll show you why this doesn't work in a second. So look here. So you can see that something's wrong here. You can't do a Tabulate command with a continuous variable because the problem is continuous variables have a lot of data, so it's harder to really use that. Now what you want to do, okay, let me tell this. If you want to compare how a continuous variable is distributed by a dummy, then you want to use something called a two-way graph. Now a two-way is just done by saying two-way, and you put in two brackets for two separate graphs, okay? Now, say I wanted to compare the distributions of working job tenure weeks for men and women, for example. Okay, so what I would do is I'd write a k-density graph, all right, and then I would go for, well, what were we measuring? We were measuring job tenure weeks, okay? So we're going to write job tenure weeks, okay? And then we're going to write the if command, if gender dummy, underscore dummy, equals 0, equals, remember. So that is the graph for men. We're going to then copy this graph and paste it into the second box, and we're going to change the gender dummy to 1. Now what this is going to give me is it's going to give me a graph showing the proportion that is present in the Korean population. You can see here, so the first graph is always the blue one, and the second graph is the red one. So we can see here that men are much more concentrated around shorter job tenure weeks, and women generally have longer job tenure in the long run. Okay, so you can see that this is generally like that. Okay, that's a significant thing. So that's pretty much good stuff. There's also a particularly interesting one which you can do here. There's something called a graph matrix, which will help you to sort of figure out relationships in a bit more of a large perspective. For example, if you don't have time to go through all of them. So if I wanted to include, let's say job tenure weeks, and then salary, Remember, all of these will have to be continuous variables, so just remember that. Work hours, age, firm size, let's say, what's other ones? And household size, let's say. I would create one that looks like this. So this is a graph matrix. Oh, hold on, I need to enlarge it. There we go. So a graph matrix basically gives you all the continuous variables and plots graphs for them. Okay? It's quite useful, right? So we can see here, so age, for example, if I wanted to look at, let's say, this graph over here, okay, I would know that age was the y-axis, and the length of job spell in current weeks and firms is the x-axis. Generally, I would actually want to look at this, because age on the x-axis is a little better, and then job tenure goes up. We can see from this graph up here that the max level of job tenure is going to get higher with age, essentially, which is to be expected, right? We can also see that there are very weak relations between firms and stuff like that, apart from this, which is just, there's a weird spike in weekly work time hours around sort of this area, which could be possibly explained by policy. Okay, there's a lot of other ways to do stuff like this. For example, you could also do a H-box plot if you were feeling a bit weird about it. So for example, if we wanted to analyze what we just did here, instead of doing a tabulate command, we do a graph H-box plot using, basically, we'd do job tenure weeks, and then we'd write by, bracket it, main job dummy. And you would get a box plot. Factor variable operators not allowed. Did I write it incorrectly? By foreign missing. Weird. H-box. Was it not H-box? Oh, maybe I can write GR. H-box. Factor variable operators not allowed. Did I do it incorrectly? Did I mess up the... Hold on, maybe if I switch around the variables there. By the main job dummy. Well, job tenure weeks. By main job dummy. Did that work? Yeah, it's just... It's not this factor variable operators not allowed. Weird. You used to do that. Weird. I think maybe the by thing. Oh yeah, I think I need to put a comma between that and the by. Hold on. Yeah, you need to put a comma there. Okay, so we can see that if the job is not the main job, the distribution looks like this. Obviously, you have a shorter job spell. And then if it is the main job, you have a longer job spell. That's not a particularly interesting statistic, but it's just something to see here. We could also even do it by household size, but that's going to generate a lot of them. But just be ready for that. You generally want to generate it based on very dummies that have, yeah, oh my god, look at that. So you can see that pretty much for 7 and 8, there were very few households with 7 or 8 people, so that's why you don't have those things there. But you can see sort of the distribution for that there. It's important, all right? Now, I don't expect you guys to learn how to use stata perfectly during this time, but this sheet would definitely help you guys, I do think, and hopefully I can help if you guys have any problems. There's a lot of different ways to sort of look at things in this. There's a lot of different stuff to see. I mean, I could even do like a just t-test job tenure weeks or something like that to see if it was significant. Oh, by, yeah. By what? Shall we do like by gender dummy? And that would be like a t-test there, for example. So you can see that like oh yeah, there's also a tab stat, isn't there? So you can tab stats any variable you'd like, so age, for example. That would just give you the mean, really. But you could get a lot more there. So you can tab stat age, job tenure, weeks. There's also a way of doing it, which is like a bit more refined. Hold on, let me just get tab stat. Let's tab stat. Where is it? It says it's on this page, but I can't see it. Summarize data. Here we go. Yeah, stat. Yeah, hold on. You also want to say stat mean. Well, yeah, mean SDM. Yeah. Hold on. Is it a comma between that? Yeah, it is a comma. So and that would generate for you. So you'd see that you pick your variables and then you pick the values you want for them. So this would give me the mean, the standard deviation, and the number of variables that I was covering. Anyway, I think that's all. If you guys have any more questions, feel free to let me know. But yeah, have a nice day, and yeah, I guess I'll see you guys around. Bye.